Remember, derivatives and integrals are opposites, so if you took the derivative of the integral of 5x plus 9, that would be similar to taking the square root of 5x plus 9 squared. So since square root and squaring something are opposites, that's kind of like what you're doing here. The answer should be 5x plus 9. And you could do the integral of this and get that answer. Take the derivative of your answer, you should be back to this. And so that's kind of what this is all about. Now, if you take the derivative of the integral from any number to a variable. So these are pretty easy. You just plug the what's up here down into here. And then remember that we're not just taking the derivative of an x, but rather a 2x up here, so we'll multiply all this by 2. It's like the chain rule. Derivative of the peanut would be 2, so this would be 10x plus 9 times 2 for that, which would be 20x plus 18. So the second part of the fundamental theorem is really easy, especially when there's just an x up here. You just plug the x straight down into here. Remember, if there's anything else up here, so if there's anything else besides an x up here, I forgot to put a dt on this, then what you'll want to do is rewrite your 10. This goes here. And then times the derivative of what's up here. So all that times 2x, which would be 20x cubed. And you could actually find the integral of this, plug in your upper bound, plug in your lower bound, get all that, take the derivative of all of that, and you would be left with 20x cubed at the end. So this is just a shortcut way. If you see this kind of scenario, instead of taking the integral of 10t, which would be 5t squared, and evaluating that from 7 to x squared, which would be 5x to the 4th minus 5 times 49, and then doing the derivative of that. And the derivative here would be 20x cubed minus 0. Yeah, you get the same answer. If you do it the long way or the short way, you're going to get the same answer, so you might as well do it the short way, which is to plug in your upper bound. Usually you're done if the upper bound is just an x, but after that, if it's not just an x, you'll want to multiply by the derivative of the upper bound. Chain rule, remember, multiply by the derivative of the peanut. So this is why, on another note, this is why it doesn't matter what number you have down here. Doesn't matter what number you're plugging in here. Eventually, when you take the derivative of whatever that number is, that all goes to 0. So that's the second part of the fundamental theorem.